All right, this is a geometry review. The key things you need to know for the Math 7 geometry unit. So similar figures, finding missing sides. They give you a big triangle, they give you a little triangle. They say it's similar, we just need to figure out the missing side. So you need to solve for n. You're going to go ahead and set up a proportion between the two. You're going to set it up big to small. I recommend you look at one of the shapes and get those measurements in either the numerator or denominator before you start looking for corresponding sides. I'm going to go ahead and tune into the big shape, and I see that the big measurements that they give us are the 12 and the 15. Then we want to start looking for their corresponding sides. If we look at the two pictures, we see that 12 and 3 correspond, so they're going to go in the same ratio, as well as the 15 and the n. They're going to be in the same ratio, so I'm going to put them in accordingly. To solve for n, I did show you the little trick you can use on calculators in class where you do 15 times 3 divided by 12. I'm going to go ahead and show the cross product rule here, where you have 12n equaling 15 times 3, which is 45. You divide out the 12, you end up getting 3 7/75 inches. So n is 3.75. You're not always going to get whole numbers for these, so sometimes you'll get these decimals, or you can have it as 3 3/4 you could have left it as. Just be aware they're not always going to work out to nice whole numbers. If you want, you could pause it and see if you can figure it out. With this problem, kids start to panic because they see the variable n, but they don't see any other measurements. So they panic and think, oh, I don't have any other corresponding sides to figure out, so I can't solve this. But in the original statement, let's just read this statement. If the ratio of the corresponding sides is 4 to 1, solve for n. We're tuning in to this 4 to 1. That's the common ratio between the sides. So they're telling us that everything should work out to 4 to 1. Now, if we're doing big to small, 4 is the bigger side, 4 is the bigger number, so that's going to be the numerator, big to small. So then you figure out what corresponds to n. You want to be careful. N is the smaller side of these two parallel sides. So down here, 16 is the smaller side of these two parallel sides. So n is from the big shape, so it's going to be n over 16. From here, you could do the 16 times 4 divided by 1. I'm going to go ahead and show the cross product rule where you have 1 times n equaling 4 times 16. So the work's pretty much done. 1n is the same thing as n, and then 4 times 16 is 64. So your mystery side on this one was 64 centimeters. Okay, so now we need to just see if these two shapes are similar. Are they similar? What we're going to do, they don't give us any numbers, but we can make some decisions based on the angle measurements. If these triangles were similar, all of the corresponding angles should be congruent. They should have the same measurements. And right away we see 20 and 15 don't match up, 70 and 75 don't match up. These two corresponding angles are not congruent. Yeah, the 90s match up, the right angles match up, but we would need all three pairs of angles to match. They need to be congruent, all of them. So the corresponding angles are not congruent. So no, these triangles are not similar. Let's take a look at another one. So we have this picture. Are these similar? We see the 20s, the 70s. Everything seems to be matching up. We've got the 90 degrees matching. All three pairs of angles correspond and are the same. All corresponding angles are congruent. Yes, these triangles are similar. Now, if they gave us numbers also, if they gave us some measurements for the sides, we would want to make sure all of those are proportional, but based on the information given here, they are similar. Like I said, we'd want to double check measurements of sides if they gave us some measurements, because sometimes they'll trick you and put in some, like on a test, sometimes they'll trick you and give you some numbers that don't really line up and are proportional. Alright, so now we want to figure out if these two triangles are similar based on the sides. We want to set up a proportion between the corresponding sides. I'm going to do big to small. I'm going to go ahead and tune into my big measurements first, and I see the 8 and the 7. Those are the measurements from the big triangle, so I'm putting those in as the numerator. And then we're going to tune into the corresponding sides. 8 corresponds with the 5. Hopefully, 8's the longer side of the big triangle, 5's the longer side of the small triangle. And 4 is the shorter side. So we have them set up according to corresponding sides. If this proportion is true, the cross products should be equal. So I'm going to do the cross product test. Is 8 times 4 equal to 5 times 7? No, they are not. So these two triangles are not similar. Okay, moving on. Similar figures based on descriptions. This statement, a lot of kids have a hard time reading this statement. We need to make sure we understand how to read this. This says triangle LMN is similar to triangle BCA. That's the first thing you need to understand. So then they're going to give you this question. And a lot of kids might have a hard time reading this, but when you read this to yourself, you should read it as angle N is congruent to something. Kids will panic because they don't see a picture. All you need to do is see in the description, see what corresponds with N. Vertex N corresponds with vertex A. So that means you're going to have those two angles be exactly the same. So angle N is congruent to angle A. That's how you'd read it. I'm going to give you another one here. We have this LM with a line over it. That's really read as line segment LM. So on a triangle, you've got your side LM. Line segment LM is going to be proportional to some other line. Well, if we look at LM up here, L to M, it lines up with B to C. So in this other triangle, side BC, line segment BC, will be proportional to it. If you set those two up, you could use those measurements to figure out what your common ratio is for your triangles. Quadrilateral family tree. At this point, you should try pausing the video and try drawing the quadrilateral family tree like we talked about in class. This is where, go ahead and pause it. Okay, hopefully you've paused it and now you're going to look at this and go, whoa, I get this stuff. So here we go. Here's the quadrilateral family tree. First you start with quadrilaterals. Then you divide them into two groups. One group is going to have one pair of parallel sides. Those are your trapezoids. The other group is going to have two pairs of parallel sides. That's the parallelograms. The trapezoids will not be broken down into any other further subgroups, but parallelograms, you can break them into two groups. Parallelograms that have 90 degrees are rectangles. Parallelograms that have all sides the same are rhombuses. You might also see the word rhombi for plural for rhombuses. And then you have rectangles and rhombuses. They kind of merge back together because a parallelogram that has 90-degree angles and all sides the same is a square. So screenshot this, memorize this. This is a really good tree to have, because then when you start asking about, like, are all parallelograms squares? No. But are all squares parallelograms? Yes. If the name is underneath the other names, it's going to be part of those groups. So a rhombus isn't necessarily a square, but a square is always going to be a rhombus. That's when you have those kinds of questions. True or false? If a quadrilateral has all sides congruent, it will always be a square. So think about it, all sides congruent, it's always going to be a square? False. The figure might be a square, but it could also be a rhombus, because rhombi also have all sides congruent. Here's another one. True or false? A quadrilateral with opposite angles congruent will always be a parallelogram. Opposite angles being congruent, that means if one angle was 30, its opposite angle would also be 30. This is true. Rhombuses, rectangles, and squares all have opposite angles congruent, and they're all falling under the parallelogram family. Opposite angles are congruent. Rectangles, yeah, the angles are 90, but even opposite angles are 90, so that means the opposite angles are congruent. All right, that's about it. Hope this helps. Best of luck to you.